Alright, so the first question is asking, what is the measurement of the angle measurement of a circle? And kind of explain your answer. So, depending on the activities you complete in the class, you might be giving this explanation a little differently, but the actual answer to what's the angle measurement, whether you did this with pattern blocks or whether we did this through a discussion about the different classifications of angles, the answer for both of these, the answer for this question in both situations is the same. So for a circle, the angle measurement is 360 degrees. There actually does exist an angle measurement called circle angle, which is 360 degrees. And the measurement of 360 degrees is actually based on a Babylonian calendar. At one time, the Babylonians had a calendar year of 360 days, 6 months at 60 days per month. And mathematicians decided to keep the 360 even though there's not 360 days in a calendar year, because 360 has a lot of factors. Factors are numbers that you multiply together to get to a certain answer. So I believe 360 has something like 24 factors, which is a lot. For example, 12, the factors are 1, 2, 3, 4, 6, and 12, so there's 6 factors. So having over 20 factors for a number doesn't happen a lot, especially for a number that isn't above 1,000. So for the second problem here, we're actually using these 3 segments to put together a segment that has a certain answer. So all of these are going to be x, y. So we're starting at x, and I'm asking you to take the AB length plus the CD length, take away the EF length, and then where would the endpoint y be at to come up with this distance xy. For the second problem, I'm asking you to take 2 AB lengths to make the final length of xy. And then the last one, an AB length, and then 3 CD lengths, and then take away 2 EF lengths. And so where's the length of xy? I'm not going through the construction. At this point, I would definitely do Monday's a little bit harder to do on the screen, but I'm hoping you can work together with a classmate. We'll go back to that handout from Monday, take a look at the, so we had a 2m plus k for one of them on Monday, and we had a 3k minus m also for the second example on Monday. See if those that first page can help you do these constructions here. Okay, so starting here, this is the work we have been doing. I would like you to name each object with 3 different names. And we talked about the fact that anytime we name things, we can use points, we can use lowercase letters, and even sometimes we can use a number, not as an angle measurement, but a number being for an angle that says this is like angle 2 or angle 5. And sometimes numbers do get used. So go ahead and you're finished writing down the names, turn the video back on, and then we'll take a look at the next set of problems. All right, so anytime you have a line segment, or an angle, we can write the name one way, and then we can reverse the letters. So one name would be line PQ. If I reverse the letters, it would be line QP. The only shape we've talked about where you can't reverse the letters is going to be the ray. And then out here to the right, they actually have given you another name for this line. It's M. Anytime you see a lowercase letter especially, it's usually an indication that this object is getting named a different way. It's an alternative actually to using points. For the second one, we have line segment AB. I can reverse the letters and call it line segment BA. And then we have this lowercase letter again, J. So this segment can also be named J. So in problem 4 and 5, we're going to be setting up some algebra problems. And to be honest with you, once we start doing some algebra, I continue to do a lot of algebra throughout the chapter because, again, we're making sure that as we approach your SAT test, especially if you're a junior this year or as you approach it for next year, that we don't lose those algebra skills between now and, let's say, Algebra 2 or the SAT test. We just talked about the fact that the sum of the angles of a circle is always 360 degrees. So I would like you, the first problem here, I would like you to write an equation that we could actually use to solve for x, based on the fact that the sum of the angles of the circle is always 360 degrees. We have two examples, so I'm going to do the first one here, and then do a little bit of time work on the second one, and we'll take a look at the second one. So go ahead and try the first one, turn the video off, turn it back on when you're ready to continue. All right, so hopefully in this equation you said equal to 360 degrees, so we have three angles here. We want all three angles to add up to 360. So 8x plus 5x plus 22, those three angles have to have a final answer of 360 degrees. If I add the like terms, which is the 8 and 5 x's, I get 13x plus 22 equals 360. If I subtract 22 from both sides, I now have 13x equals 338. And then to undo the multiplication problem, we're going to divide both sides by 13. So 338 divided by 13, and the answer is 26. So if I would go back to the problem and take 8 times 26, that would be the actual measure of the piece on the left here, which is 208 degrees. If I take the other piece and take 5 times 26, that's 130 degrees. And so if I add 208 to 130 and then the 22, the third piece, those three answers should add up to, which they do, 360 degrees. That's kind of our check. So the first answer is 26. Go ahead and take a look at the second problem. Set the equation. Solve for x. Turn the video back on and we go to. So in this problem here again, we are setting the angles, there's 4 of them this time, equal to 360 degrees because again we have a circle. Now they didn't actually continue the circle here, but those 4 angles are all around this single point, which makes a circle angle. So we have a 90-degree angle, that's that little square, plus an x, plus a 3x. Those are our 4 angles. And those 4 angles should add up to 360 degrees. So I'm going to stop here for a moment. If you didn't get the equation set up, now that it's set up, go ahead and solve for x, turn the video back on and you're ready to continue. Alright, so if I combine like terms like I did in the first problem, it's going to be 90 plus 5x's equals 360. And then we'll take away the number 90 from both sides. Put the 0 here, so 5x is going to be equal to 270. And then we're going to undo the multiplication problem of 5 by doing division. So x is equal to 54. So if this is 90, this angle here is 54. That's the answer for x. This angle here is also 54. And then if I take 54 and I triple it, I get 162. So if I take those 4 angles, 162, plus 54, plus 54, plus 90, hopefully, reading correctly, that's going to add up to 360 degrees. And let's double check, and it is 360. So x has a value of 54. So again, if you're not perfect at this point, that's fine, because you're going to see more of these problems next week, and then as we get into even chapter 2, you're going to see more and more of these algebra problems. So you'll get better at them if you do get even of these right. Now in problem 5, instead of doing the full circle, these are all half circles. And so basically, a half circle is creating a straight line or a straight angle. So since it is a half a circle or a semicircle, we're basically looking at an angle measurement of 180 degrees. So instead of our equation being set equal to 360, Now we're going to be looking at equations that equal to 180 since we're only talking about half a circle. So if you go ahead and set up the first two, so I'm going to call problem 1 and 2. Set up the equation, and if you're comfortable with it, go ahead and solve for the single variable and then just continue on. If not, turn the video back, turn the video off when you're done, turn it back on, and we'll take a look at these two problems, and then hopefully if you're struggling with these, and after you see them done, hopefully that will help you with the next couple of problems. All right, so for both of these, I'm going to set them equal to 180, since it's a half circle. So I have two angles for problem 1, 70 and x. I'm going to add those together. And I'm going to solve for x. I'm going to subtract 70 from both sides to create a 0 on the left side. So x is equal to 110 degrees. So 70 and 110 added together is 180. In the second problem, I got a 72-degree angle, A angle, and a 63-degree angle. If I add the 72 and the 63, because they are like terms of their numbers, or constants, I get 135. So if I subtract 135 from both sides, I end up with A being 45 degrees. So if I add 72, 45, and 63, the final answer should be 180. Go ahead and continue on to the next problems. I'm going to call this one 3 and 4. Turn the video back on when you are ready to continue. So in problem 3, it's going to be x plus 92 plus 33 equals 180. 92 and 33 are like terms, so we count x plus 125 equals 180. Subtract 125 from both sides, you get x is equal to 55 degrees. I'm going to leave 4 for you to work on. I'm not going to go through the steps for that. 5 and 6, I'm going to talk about 5. I'm going to leave 6 for you to work on. Again, I'm not going to give you the answer at this time. It's something to talk about on Tuesday. So for problem 5, we have 3 angles. We have an x plus 10 angle. We have an x angle. And we have a 2x plus 10 angle. And because we're talking about a half a circle, these 3 angles, when added together, should add up to 180 degrees. So I'm going to kind of leave it at this place here, and if you haven't figured it out, this is the equation, x plus 10 plus x plus 2x plus 10 equals half a circle over 180. Go ahead and solve it and turn that video back on when you're ready to continue. So we have x and 2x, that's 4 x's, plus a 10 and a 10, which is 20, is equal to 180. Take away the 20 from both sides. If I subtract 20 from both sides, I get 4x equals 160. And then if I divide both sides by 4, I get x is 40, which is the final answer for this problem. X is 40. So again, I'm going to leave problem 6 for you to work on. At this point, we've been talking about, we measured angles back in the first handout called Drawing and Measuring. I've asked you some additional work with protractors. What I've done here is kind of set up a little bit of conversation about what angles are, how we name them in terms of vertex and side, which we've already talked about. I'm asking you to measure these, and then I'm giving some additional information about placing that protractor. So these are things we've talked about a little bit, but just more clarification. Talk about the fact that with angle measurements, we don't actually measure reflex angles. We just keep to the 0 to 180 side between those two. So basically, we always measure angles that are acute by obtuse. Talked about that just recently, but we'll continue to talk about that as we, depending on which class you're in. Some of this is maybe more familiar than others, and that's fine. And then here, I'm asking you to name some angles, and then here, I'm asking you to tell me what the measurement is. So if you've actually did the activity where you actually name the angles as in problem number 7, I would like you to go ahead and do that. If your class has not done number 7 yet, then I want you to skip that during this class time. So complete the rest of this activity, do as much as you can, but again, problem 7, one group is done already, the other group is not.